Okay, good morning students. Today we have the second lecture on vectors. This is addition, subtraction and multiplication of a vector. Now, see, with respect to my first lecture, so the vector is basically represented by an arrow, right? So, and usually, suppose this is a p vector, this is the sign which is given, this arrow. But I have a habit of giving this, so these are equivalent, never mind. Actually I do problems very fast, so these type of writings help me a lot. Anyway, it depends upon the pattern. So I have a habit of writing this, I'll use this. So this is p vector, right? And um, and suppose there is another vector. So this is q, right? So this is p, this is q. Okay, I keep it like this. And suppose I want p plus q. So what shall I get? First, there are few things which you need to know. If you translate a vector keeping it parallel to itself, the vector doesn't change. How? Well, suppose this is q vector, right? And you translate this keeping it parallel to itself, this is also q, right? This is also q. Now what you do is you translate this so that the starting point of this q comes here. So let me erase these things. So this is q. Okay. So these two are parallel. Now, so naturally from simple geometry you will see that this will be p, right? This will be p. Anyway, so q, place it here, and this is p. So this p plus q. So p plus q. What's the resultant? This. So this is p plus q. Okay. Now, first I have gone to addition, then let's try subtraction. So this is addition. Now subtraction. So I want p minus q. Again, you need to know something here. Suppose this is p. This is p. And similarly, you have q. Okay. Q. What do you do? First, you need to generate a minus q. Basically, this is equivalent to p plus of minus q. Now, minus q, vector subtraction is basically a vector addition. With basically a vector addition, you just change this q to minus q. So what you get if you change the q to minus q? First, see the geometric view. Suppose if you have q, right? Then what is minus q? Everything is the same except the direction of the arrow changes. So if this is q, so this is minus q, right? So if this is p, this is q, what will be minus q? So this is minus q, right? So now you are basically adding minus q with p. See, you are basically adding minus q with p. So what do you do? So you just simply, let me write subtraction here. You simply translate this minus q here. So this is minus q vector, right? Now you just join these. just join. That's all. So this is P minus Q. It's basically an addition. Subtraction is basically a addition. Now here another thing which I have already written here and I have already done implicitly, just check, is scalar multiplication. Scalar multiplication means multiplication of a vector by a scalar. So what I have done is I have multiplied minus 1 with Q, see. So minus Q. So if I take this topic, scalar multiplication. So minus Q is basically minus 1 times Q. So if I multiply minus 1, what happens? Suppose if this is Q, the direction changes. Everything remains the same. Now suppose if I multiply 2 with Q, what happens? Suppose this is the first part, this is the second part, 2 with Q. What happens is, let's reduce, take another vector, 2 with B, let's shorten a little bit. Suppose this, okay, let's take another vector, say P vector. This is not the same P here. So what is 2P? 2P means you take P, then you take another P. So P plus P is 2P. So what's the resultant arrow? This. So this is 2P, right? If this is P, this is 2P. Multiplication of scalar by a vector is just a scalar sitting side by side with a vector. There is no operation. Mind it, there is no operation between a scalar and a vector. When you age, you will understand vector space. This is basically a field member. These vectors are components of vector space and this is defined over a field, and this is a field member. You will learn this as you age. So 2 times P, it's scalar times a vector, that's how you read it. Minus 1 times Q. Okay, minus 1 times Q. Suppose you want half P, what do you get? You already have a P, you get the half the length of the arrow. Suppose right, minus half P, what do you get? It's the same arrow, this is the P, take half of it and just flip it. You get the minus half P, right? So this is the geometric view of scalar addition, addition of two vectors, subtraction of two vectors. Subtraction is basically an addition, and this is scalar multiplication. Scalar multiplication means multiplication of a vector by a scalar. Now the next step what I shall do is I shall find the resultant, means the geometric length of these things, right? Geometric length of these things. Before that, I want to tell you something. Suppose you need to place a vector with respect to some frames. So dependence on frames. This is a very important thing. First I shall tell you, then we will go into resultants and all. So frame dependent vectors, frame dependent vectors. vectors are usually frame dependent, because for example, suppose I draw a vector, right? So now if I move the board, suppose if I move the board, what happened? So if I move the board, what happens? This vector changes direction, right? So it can't be like that. You are representing something with respect to something, right? I tell you, suppose this is the east direction and suppose this is north, and a ship is moving 30° north of east with a certain velocity, suppose 10 nautical miles. Now, so suppose it's moving in this direction. Now, with respect to east, it is 30° north of east. Now, you place a frame. Now, if you rotate the board, the frame also rotates. So, it's not a problem, right? So, the vector doesn't change. Vector is static with respect to this frame, this is this north. So, this vector is frame dependent. You must have a frame, and with respect to that frame you must draw the vector. So, that is important, and this is my board and this is the frame. You can take it like this, that this is the x-axis and this is the y-axis. What I am doing, it isn't doing in 2 dimension. We'll extend it into 3 dimensions. That's okay. You can extend it into n dimensions as well as you age. So that is a different thing. So these are frame dependent vectors. For example, if you say this is as the x-axis and this is as the y-axis, and suppose if you this part has some component here, suppose 10 cosine of 30°, and this is 10 sine of 30°. This you know from your early school days. Because cos 30 is, and this is sine 30 is half, so this is 5, 10 by 2 is 5. So these are the magnitudes of along the east and along the north, right? So you can have components as well. You can write this in terms of components. Whatever it is, so direction, the component of velocity along the east direction is fixed, component of velocity along the north is also fixed. So you go to my next videos, unit vectors and all, you will see how I have represented vectors in terms of components. Anyway, so let's find the magnitude of the resultant in terms of the other 2 vectors. Remember that I have drawn all the vectors, p vectors, q vectors, etc. with respect to some frame. So keep that in mind. Okay. So resultant of 2 vectors. Suppose I am drawing a frame. This is x and this is y, and I have 2 vectors, okay, p and q. So p plus q I need. Now do one thing, see, if I place p here, right, let me draw this axis in green, so that will help you a little bit. So this axis are in green, and suppose this is p vector and suppose this is q vector. So what is p plus q? You just translate this p or this q, keeping it parallel to itself. So translate p, we can translate p as well, it's not a problem. So this is p, and just join this. Okay. Okay. So this is q q, and this is p plus q. And suppose this is the angle between them, theta. So what I need to know, we need to know the length of this arrow and how much this arrow is inclined with the x-axis. So this angle also, this angle is alpha. So we need to know r, so that's the magnitude of r, and alpha, right? If I, and given p, q and theta, sorry, p, q and theta, angle between p and q. So given these theta, we need to know r and alpha. That's all. That's what I need to do. So what shall I do geometrically? Using dot products I have done, that's very simple. The more you, the higher the mathematics you learn, the physics will be more simpler to you. That's my also tactics of teaching. What I do, I teach mathematics a little bit higher so that life becomes simple. Never mind, that's okay. Now first do one thing, just drop a perpendicular from this point to this point, right? Just name them. So this is O, this is A, this is B, this is C, and suppose this perpendicular is D. Okay. Now from simple geometry, so the magnitude of this is R, the magnitude of this is Q. Now what is BD? BD. Now suppose if you place an arrow like this, this is basically the magnitude. So this is the same thing, right? BD. Now this is, from geometry you can automatically say, so this is also theta, the corresponding angles, and if this is Q, so BD is Q from triangle, right? From triangle law. What do you do? Let me explain a little bit. So use this triangle first. So from triangle CBD, what is sine theta? Sine theta is opposite by hypotenuse. So that is, what's the opposite? Opposite is BD, right? What's the hypotenuse? BC. Okay, BC. Now plug in the values. What is BD? BD I do not know. So this implies BD is equal to BC. Sorry. BD equals to BC sine theta. What is BC? BC is Q. So Q sine theta. Similarly, if you take cos theta, so from the same triangle CBD, cos theta is adjacent by hypotenuse. What is adjacent? Adjacent is CD, and what's hypotenuse? Hypotenuse is BC. So this implies CD is equal to, this CD is equal to BC cosine theta. So that is Q cosine theta. Fine. Now use this triangle. From triangle OBD, from OBD, right? OBD, if I use Pythagoras theorem, if I use simple Pythagoras theorem, so since this is 90 degrees, this is 90 degrees, just drop a perpendicular solid, that's okay. OBD, from this OB, from this triangle, this square plus this square, so this is BD square, right? BD square plus OD square is equal to OB square. So I need OB square, right? Or OB square is equal to, what is BD square? BD is, we have already found it, see, this is q sine theta, right? So q sine theta whole square plus q sine theta whole square plus OD square. OD square is basically what? OD square is, OD is equal to OC plus CD, right? So OD square is OC square plus OC plus CD whole square. What is OC? OC is P. P plus CD. CD I have already found it, Q cos theta whole square. Now just expand this. Q square sine square theta plus P square plus Q square cosine square theta plus 2PQ cosine theta. Fine. And this is basically R square. That's the resultant square. Now, if you see from this and this, Q square sine square theta plus Q square cos square theta, what do you get? So Q square sine square theta plus cosine square theta plus P square is equals to 2PQ cosine theta, right? So this is an identity. Sine square theta plus cos square theta is 1. It's always 1 for any value of theta. So that's an identity. So you can write this as 1. So you can just simply remove the 1 into q square is q square. So you can simply remove this and you can write this as q square, right? So it's q square plus p square plus 2pq cos theta. So that's the resultant. Or you can write it like this. You can just place a half here. You must take a magnitude. So this is positive, right? So I'm not taking, it's not plus minus, it's only plus. So since this is a magnitude, this is only plus. Okay, so this is the resultant of the vector. Another thing which we need is alpha. It's very simple. From this same triangle, so you can remove this part and you can write from triangle this OBD, tan alpha is equal to this by this BD by OD. So what is BD? Q sine theta. And what is OD? OC plus CD. OC is P plus Q, CD is Q cos theta, right? So remember, when you write tan alpha, the basic way to memorize this tan alpha is, first, if this is alpha, take the opposite vector first. So Q sine theta divided by, the denominator should be P plus again Q cos theta. You start with this, not the adjacent vector, rather the opposite vector, or the non-adjacent vector to this alpha. So P is attached to alpha. Don't start with this, start with this. It's Q cosine theta divided by P plus Q cos theta. So these are the two formulas for resultant. We shall deduce this. I have deduced this already in vectors of dot product. It's very simple to deduce R. R is basically P plus Q dot P plus Q. I have already done it, right? So refer R square is this. So refer dot product video. It's lecture 4 in the series of vectors. So that's the simpler way to do it. Anyway, we shall carry with components of a vector and how to manage components and how to do this simple algebra using vector components in the next lecture. Thank you very much.